Hello, welcome to this guided surgery webinar by Versah. My name is Todd Marshall. I'm the Chief Operating Officer here at Versah and the lead engineer for the Versah guided surgery system. The Versah system is a very simple, universal, and precise guided surgery system for the Densah Burs. During this webinar, I will be reviewing the components of the system, including the C-Guide, how to assemble them, reviewing treatment planning softwares with the system, including Co-Diagnostics and Bluesky Bio, guide fabrication, drilling protocols with the system, and reviewing some great cases completed by clinicians across the world with the Versah guided system. The Versah guided system is not like standard surgical guides on the market. Standard surgical guides can be a closed restrictive design that limit visibility to the site, irrigation flow to the site, as well as difficult to manage in molar regions because of clearance issues. The systems themselves may incorporate handheld keys, which further complicate the surgical protocol for the clinician. I relate the standard surgical guide to a drill press. Drill press is a very restrictive drilling path for the clinician, one path in, one path out. Can be challenging in the molar regions, and this type of closed-off restrictive system does not work with the Densah Burs and Osseodensification. These types of closed-off systems can also create issues with heat generation. When you restrict irrigation flow to the site, heat generation can be an issue. Lou studied these restrictive systems. He studied the effects when you restrict irrigation flow to the site, what effect that has on the bone, and he found heat generation can be an issue, sometimes even to the point at which bone necrosis may occur. The systems themselves are not optimized. They're overly complicated, including many parts and pieces that further complicate the drilling protocol for the clinician. The Versah guided surgery system is different than the standard surgical guide. We purposely designed it more open to help with the osseodensification process. It's a universal design that's compatible with most implant systems on the market, simple and very precise with its implant placement. The openness I discuss allows for a lot of irrigation flow to the site, allows the clinician more visibility during the drilling procedure, and is non-restrictive to the pumping and luxating motion needed for the Densah Burs. The Versah system is optimized. It's dual mode function, meaning you can use it fully guided with a surgical guide, or you can use it freehand as a vertical stop only. The system comes in 4 sizes: small, medium, large, and extra large, and I'll explain how each size relates to the Versah system itself. First, we have the small. The small places an implant up to 3.25 millimeter in diameter and fits on the Versah Pilot up to the VS2228 Densah Bur. The small has what we call the G-Stop gauge, which is a single-use PEEK plastic, medical-grade PEEK plastic, the G-Stop key, which acts as the vertical stop for the Densah Bur, and the C-Guide sleeve, which is installed into the surgical guide for fully guided drilling protocols. The small keys come in 7 different drilling depths, ranging from 3 millimeters up to 15 millimeters. We designed the 3 and 5 millimeter G-Stop keys to help with the sinus applications. They work very well in the sinus. Also with the smalls, we are introducing our new short Densah Burs. Our short Densah Burs are a 33 millimeter Densah Bur, 33 millimeters in length, and you can use the same G-Stop vertical stops on the short Densah Burs as you do the regular Densah Burs. With the short Densah Burs, you will use the same keys as a vertical stop as you do the regular Densah Bur, and we have 5 drilling depths available. So the 15 millimeter drill stop that worked on the regular Densah Bur will be your 10 millimeter drill stop for the short Densah Bur. The 13 millimeter on the regular Densah Bur is now your 8 millimeter drill stop for the short Densah Bur. 11.5 becomes your 6.5 Your 10 millimeter drill stop on the regular Densah Bur is now your 5 millimeter on the short Densah Bur, and your 8 millimeter drill stop for the regular Densah Bur now becomes your 3 millimeter drill stop for the short Densah Bur. Next, we have the medium G-Stop. The medium places up to a 4.3 millimeter implant diameter and works on the Versah pilot drill all the way up to the VS3238 Densah Bur. The medium has the same G-Stop gauge that's again single case use, the medium G-Stop keys, which are reusable, and the medium C-guide sleeve, which is installed into the surgical guide sleeve. The medium includes the same 7 drilling depths for the regular Densah Burs, ranging from 3 millimeters to 15 millimeters. Again, we included the 3 and 5 millimeter drill stops for the sinus applications. For the short Densah Burs, the medium will fit on the short pilot up to the short VT2838. And again, the medium includes 5 drilling depths for the short burrs, ranging from 3 millimeters up to 10 millimeters of drilling depth. The large size places implants up to a 5.3 millimeter implant diameter and fits on the Versah pilot all the way up to the VS4248 Densah Bur. Again, the large has the same single-use G-Stop gauge, the multi-use G-Stop key, and the single-use C-guide sleeve. The large includes 7 drilling depths for the regular Densah Burs from the 3 to the 15 millimeter drill depth. With the short Densah Burs, the large will fit on all of the short Densah Burs, from the pilot drill up to the VT3848 short Densah Bur. And again, with the short Densah Burs, we include 5 drilling depths from 3 millimeters up to 10 millimeters. For the extra large, you can place up to a 6.2 millimeter implant diameter, and the extra large will fit on every Densah Bur and pilot. Again, the extra large has its own G-Stop gauge, G-Stop key, and C-guide sleeve. The extra large has 7 available drilling depths for the regular Densah Burs, from 3 millimeters up to 15 millimeters, and the extra large will fit on every short Densah Bur as well. Again, with the same 5 drilling depths for the short Densah Burs, ranging from 3 to 10 millimeters. For the Versah system itself, we designed irrigation slots into the G-Stop keys. These are very important for promoting a lot of irrigation to the burr. We want to make sure that that irrigation hits the Densah Bur and flows down the burr for proper operation of the Densah Burs. To assemble the G-Stop keys, first you look for what we call the Densah Bur groove. This is a groove we manufactured on the shank of the Densah Bur. You can often identify it. This is right where the gold and silver meet on the Densah Bur itself. Installation is pretty simple for the G-Stop onto the Densah Bur, as demonstrated in this animation. First we have the G-Stop gauge, next we have the G-Stop key, and finally the Densah Bur. You snap the gauge onto the Densah Bur, you slide the key over the gauge, and installation is complete. From there you can swap out your drill depths as needed during the clinical procedure. As demonstrated here, once the gauge is properly installed, you should be able to freely spin the gauge on the Densah Bur. You know it's properly locked into place and ready for installation of the key. Surgical guides with the Versah system can either be single or multi-site guides and can be either tooth-supported or tissue-supported. We've designed the C-guide sleeve to be different than standard surgical guide sleeves on the market. First, we incorporated a buccal window into the sleeve. This buccal window is installed into the surgical guide as well. This helps with irrigation flow to the site, visibility to the site, as well as allows for a side access in the molar region and smaller openings. We've also included a 1 millimeter lip into the C-guide sleeve itself. This lip is the stopping point for the G-Stop vertical stop within the sleeve. When using the G-Stop in combination with the Versah C-Guide, you'll need to account for this 1 millimeter lip built into the C-Guide itself. So if you're using a 10 millimeter G-Stop, you need to subtract 1 millimeter for the 1 millimeter lip, so you have a total of 9 millimeters for your drilling depth. Now I'm going to review some treatment planning solutions with the Versah system. There are 3 things to consider while treatment planning with the Versah system. Number 1, the clinician must reflect a flap. We always recommend a flap surgery, regardless if you're using guided surgery with the Densah Bur or the Densah Bur free-handed. Number 2 is the guide itself should be as close to the bone as possible. And number 3, you can offset the surgical guide sleeve off the bone up to 4 millimeters based on the anatomy of the ridge. Versah is currently compatible with 3 main treatment planning softwares, including Co-Diagnostics, Bluesky Bio, and Implantation. We are working with many more software providers to provide compatibility in the near future. Next, I would like to introduce Josh from Dorsey Dental Lab. Josh put together this recording demonstrating treatment planning with the Co-Diagnostics software.
Okay. So anyway, this software here, let me start off at the beginning. So we can superimpose a 3D model after it's been scanned or an intraoral scan into the program so that this way we can use this to make the guide. You absolutely need that, plus the multi-file DICOMs that I explained before. So starting off first, we're going to kind of want to set up the video of the patient real quick, make sure that we're looking straight facial. That was that view from before. We're going to go ahead and make a panoramic curve along the ridge line, just so that this way the software knows where to place the implants in the correct number. As you can see here, this isn't a true pano, but it's going to set up where we can actually see where the implants are going to go in the face, kind of like a pano. Once we get all of that done, we're going to go ahead, in this site here, we're going to be placing implant number 13. This particular case, we chose a BioHorizon implant for the case. Once you go ahead here, you have a very long list of implant companies that Co-Diagnostics has in their software already. So you can go ahead and go look through that. Straumann, Nobel, and all of those are in there as well. Now, once you go ahead and pick the implant that you're going to use, you're going to go ahead and open up this view tangentially so you can spin around it 360 degrees. You're able to move the implant. So you needed to tip the apical portion towards the palate. You can do that. If you wanted to move it a little bit more buccal, you can do that. Now, my lab tries to set up everything to be straight screw retained, if possible. Now, using the Versah system, we're able to expand the bone and get some osseodensification at the same time. So you notice that this implant is a little bit palatal to work for that buccal expansion. Now, placing in the sleeve for Versah, once we figure out what diameter implant we have, this one is a 4.2, so it's going to use the medium G-Stop. The medium G-Stop. So we're going to pick that one because it goes up to the 4.3 millimeter implant. Now, when we place the sleeve, I'm going to place it as close to the bone as possible. So if you can see over here, my distance to the crestal portion of the implant is only 2 millimeters. That's because I'm right on top of the bone. And of course, the guide is not going to fit until you flap because you need all of that irrigation for the osseodensification of the burrs. Now, to make your measurements to see which G-stop you're going to use the same distances that Todd showed you earlier, which you're going to make a 1 millimeter distance here from the bottom of the sleeve up 1 millimeter, and that's for the bottom of the sleeve. And then you're going to take your distance to the bottom of the osteotomy, which is going to be 13.5 millimeters. So now we know that we're going to be using the 13 millimeter G-stop and the medium portion of it. After that's all done, you're able to create a guide. Once you create a guide in the system on the model that you've placed here, you will come up with something like this that you can print out on a 3D printer so that you can put this in the patient's mouth and do your surgery fully guided.
Next, I will walk you through the process of how to set up the Bluesky Plan software with the Versah guided system. The first thing you need to do with Bluesky Plan is put it in advanced mode. Advanced mode is done by going to the module menu, surgical guide menu, and clicking on the advanced option. As demonstrated in this video, we are going to set the Bluesky Plan software into advanced mode, which brings up the guide tube configuration panel. And we are going to set the drill kit to a custom kit. Next, I'm going to walk you through the guide tube parameters. I've defined each parameter for easy setup with the Versah system. So the guide hole diameter for the small C guide will be 5.35 millimeters. The height will be 7 millimeters. And I will go in depth on the offset in just a little bit. For the medium C guide sleeve, the guide hole diameter will be 6.15 millimeters, and the height will be 7 millimeters. For the large C guide sleeve, the guide hole diameter is 7.15 millimeters, and again, the height will be 7 millimeters. And for the extra large C guide sleeve, the guide hole diameter will be 8.15 millimeters, and the height will be 7 millimeters as well. For the offset, we have defined a simple formula to help you calculate the offset. Number one is you're going to take the full C guide sleeve height, which is 7 millimeters. Again, remember that this height is made up of the 1 millimeter lip, which is the stopping point for the C guide, plus the 6 millimeters for the guide tube itself, which equals a total of 7 millimeters. Next, we have variable X, which is the distance from the bottom of the sleeve to the top of the bone. This typically ranges from 0 to 4 millimeters for the C guide system. And finally, we have variable Y, which is the implant level. If the implant is placed at bone level, at the crest of the bone, this will be 0. If you place the implant subcrestally, it'll be whatever level you place it at, 1 millimeters, 2 millimeters, whatever level that implant is at. So finally, the offset is a combination of 7 millimeters for the C guide height plus X plus Y. After we have the offset defined, we can then calculate which drill stop key we will need for our drilling depth. This is done by another formula in which you take the offset, you add in the implant length, and you subtract 6 millimeters for the guide tube. And this should equal one of our predefined G-stop keys, ranging from 3 millimeters up to 15 millimeters. To show you an example of how to calculate this, I've put together a demonstration using a 5 by 10 millimeter Megagen implant. So first we'll calculate the offset, which is our formula. We have 7 millimeters for the C guide sleeve. We're going to raise the sleeve 2 millimeters up off the bone, and the implant itself is going to be at the crest level, so the Y variable will be 0. So this combination of 7 millimeters plus 2 plus 0 gives us a 9 millimeter offset. This offset we can now use to calculate which G-stop key we're going to use. So we take our 9 millimeter offset plus the 10 millimeters for the implant length minus 6 millimeters gives us 13 millimeters. So we're going to use the 13 millimeter G-stop key for this plan. Next, we're going to demonstrate adding in these parameters into Bluesky Plan. So we make sure we set the drill kit to a custom kit, and we put in our parameters we have. So the guide tube diameter will be 7.15 millimeters, the height will be 7 millimeters, and the offset will be 9 millimeters, as we defined in our formulas. Once we have these parameters set up, we need to verify the drilling depth. for Bluesky plan. We do this by measuring from the bottom of the sleeve to the bottom of the osteotomy. As you can see here, we have 12 millimeters that we measured. When we add in 1 millimeter for the C-guide lip, we know we are exactly where we need to be to use a 13 millimeter drill stop. Once the parameters are entered, we then go to the guide panel in Bluesky plan and begin drawing the guide curve to create the actual surgical guide. You do this by holding down the shift key and clicking around the perimeter of your model to create the outline for the surgical guide itself. You'll want to click around the buccal side of the model and then rotate to get the palatal side. And this will tell the software itself how to create the surgical guide. Once you complete the outline, you can then create the surgical guide itself. We now have a complete surgical guide ready for fabrication by Bluesky plan. The final step in creating the surgical guide is to add a buccal window into the software. This buccal window will help create the same design that we have included into the C-guide sleeve itself into the surgical guide. To create the buccal window, you right-click on the guide and select Add Window. From there, we have entered parameters to include 6 millimeters of width, 6 millimeters of height, and 5 millimeters of depth. This should be sufficient in positioning the window exactly where we need it for the C-guide sleeve. Next, we have a demonstration by Matthew from ConeScan. Matthew is showing us the Bluesky Bio software and how he plans for Versah cases.
Hello, good day. This is Matthew Farquharson from ConeScan, and today I wanted to show a video on how we plan a case for a Versah surgical guide using the Bluesky Plan software. So a case we have here I've pulled up as a maxilla case, and it's a perfect example of how great Versah Burs will be able to work with a sinus lift procedure. So what we wanted to do today is place 3 implants in the upper left quadrant in the posterior, and how we'll do that is start by placing our implants, and for today's purposes I will be using no bowel replace. And so generally we like to plan our case based on best practices for restorative aspects as well as our surgical aspects. So I will look at the area and assess and think, okay, we can maybe place a 3.5 by 10 in there because I want to see that we have enough space to space these implants out mesial distally. And one of the things to keep in mind is with the Versah system is we don't, at any given point, we don't want to be going more than 3 millimeters into the sinus, and so we will design our plan according to those specifications. So what I'm doing here is just placing an implant here in this particular area, and we'll call it, the patient is missing one of the premolars, but we'll call this 13. And this particular case, this particular area is not going to be as complex as the other ones because we're only going into the sinus very slightly, and what we'll do is I'll just place in a custom abutment, which is not actually an abutment. I just use this for trajectory purposes. I usually make it 20 millimeters or 15 millimeters long so that we can see where the implant would be coming out on our virtual setup here. We ideally want to be directly centered in the central fossa in these areas, and obviously a safe distance away from our adjacent tooth as well as being parallel. So I think that would probably be a good setup for our first implant. And we can then also do measurements to work out exactly how far we're going into the sinus, and in this particular area on the distal aspect of the implant it's about 2.2 millimeters. So we would be able to have a nice setup for the Versah stop system here, and then we'll go further back and do something similar in the number 14 area. And then what I'll do is I'll probably place a much wider implant and a much shorter one, maybe a 5x8, and we'll see what that looks like. Now we have a bit of a slope in the back here, so it really does depend on the preference to the surgeon, whether they want to either go into the bone completely. Perhaps being in the posterior region, they may feel that they're okay with the collar being a little bit exposed on the distal aspect because we're right at the back in the posterior region there. Typically I'll always like to plan the case to be completely in bone, and then if we need to bring it out coronally, we can plan to do that. Now in this particular instance, we'll just place these 2 implants, and then we could just get to first molar region here, like we have on that right hand side as well. And then what we could do is then see, okay, well, with an 8mm implant, we can measure from the center of the osteotomy. We can either do it, I usually do that in the cross sections as well. And we can see here that's actually just slightly more than 3, which would then, we would then adjust our protocol to get the Versah Burs to go in just slightly, so that the doctor could start prepping the sinus lift, and then we can go to the next stop to get to full depth. And we would always work out what G-stop you would have to use in order to ensure that you're not going past that 3mm mark at any given point, and protect that membrane. So this is how the software with the Bluesky plan works, and then we can always customize the offset of our sleeves for the Versah system, and that will just be the height of the surgical guide and that versus the C guide sleeve, and we could either put that at 1, 2, 3 or 4mm, and then based on that we can work out exactly what stop you would need to use, whether that's the L3, L5 all the way up to the L15, and which makes the guide design process easier for the technician, as well as making the surgical procedure far more accurate, being able to adjust your heights and making sure that we're not surpassing those parameters based on the Versah system. So that's just basically a general rundown of how we design things on our end and with the Versah guided system.
We've also designed the Versah system to be compatible with the CEREC 2 system. So the small G-stop key is compatible with the small CEREC 2 hole, the medium G-stop key is compatible with the medium CEREC hole, and the large G-stop key is compatible with the large CEREC 2 hole. After you mill the CEREC 2 guide, you simply take a lab burr and cut a small buccal window into it. Then you can use the corresponding G-stop key in your surgical protocol. So again, if you milled a small CEREC hole, you can use the small G-stop keys on the Densah Burs for your surgical protocol. If you use a medium CEREC hole, you can use the medium keys. For the large CEREC hole, you can use the large keys in your protocol. Making the C-guide is a straightforward process. You can use any standard 3D printer on the market as long as it's able to print with a dental resin. After you 3D print your surgical guide, you install the C-guide sleeve by aligning the tops of the sleeve with the top of the guide, and you can use a light-cured clear composite to adhere the sleeve itself into the guide. We began studying the accuracy of Versah's guided surgery system. Can we reproducibly and accurately place an implant with the openness of Versah's system as compared to the drill press style of the standard surgical guides? So we approached this study with Dr. Arndt Gooch at Marquette University, and we wanted to study Versah's system as compared to the gold standards in the industry. First, we looked at Nobel's system in comparison to Versah's system. Can Versah's system accurately reproduce implant placement like the Nobel system can? And we found, yes, it can. there is no clinical difference between the accuracy of the Versah system and the Nobel system. The second gold standard we looked at is the Straumann system. Can Versah's guided system be as accurate as the Straumann system? And yes, it can. Our study has shown that there is no clinical difference between the trueness and precision of the Versah system versus the Straumann system. Next, I'd like to show you some clinical examples of the Versah guided system. This first one is a case done by Dr. Isaac Towell. Isaac began with installing the 15mm medium G-Stop onto his Versah pilot drill, and he drilled to depth. Next, he installed the 15mm G-Stop onto his VT1525 and began drilling to depth with the VT1525. Finally, he installed the VT2535 onto the drill stop to finish his osteotomy drilling depth. Next, Dr. Towell then places his implants. Here he's placing Megagen implants, and he's actually installed a separate surgical guide on here, which is specifically designed to help him place these implants fully guided. So after he torques his implants, he then verifies his implant depth and hex placement with the surgical guide. And finally, he checks his ISQ and has achieved very good stability with his initial implant placement. Throughout this procedure, Dr. Towell was able to drill and produce a very accurate and precise implant placement for his clinical procedure with the Versah guided system. This next case is by Dr. Richard Martin. Richard used the Versah C guide to help place his implant very accurately during a socket shield case. This next case here is by Dr. Robert Silva in Brazil. Dr. Silva put together this video demonstrating how he's used the C-Guide system in a previously extracted molar. The final case we're going to look at is this left molar done by Dr. Marcel Verlage in Poland. He began by treatment planning the process, planning his implant trajectory, placement, as well as the restoration placement, and he designed his surgical guide to accomplish this goal. He then 3D printed his surgical guide and installed the C-guide sleeve within the surgical guide itself. Next, he began his site preparation and verified the fit of the surgical guide into the patient's mouth. He then begins extracting the existing molar to preserve the septum. Next, he starts his drilling trajectory with the Versah pilot drill. First, he installs the 5mm G-Stop key onto the pilot to start his trajectory. Then he uses his final drilling depth for the G-Stop key to finish drilling to depth with the pilot drill. From there, he begins gently expanding the molar septum with the Densah Burs through the C-guide, making sure each burr trajectory is aligned as needed through the C-guide sleeve itself. And finally, he was able to gently expand and transition the socket from a Type B to a Type A socket. From there, he was able to accurately place his implant and install the custom healing abutment to finish the case. Thank you for watching this webinar. I hope you found it very informative. Please reach out to one of our many certified dental labs for all of your guided surgery case planning needs and surgical guide printing needs. If you do not find your dental lab listed in our list of certified labs, please reach out to us. We'd be happy to work with them to bring them on board. If you have any questions at all about the Densah Burs and Versah's guided surgery kit, please reach out to us. We'd be happy to answer any questions you may have and assist as needed. Thank you very much.